Ooh, I gotta look good for this. Should I go with the man bun? I don't know about that. What's up, Palm Tree? It's Coconut Daniel with a bit of a new vlog today. In this video, we will be analyzing the popular drinking game around the world, in which a player is dealt 4 cards, but before receiving each card must answer a question correctly. For the first card, the player must correctly guess if the card is red or black. For the second card, the player must correctly guess if the card will be higher or lower than the previous card. For the third card, the player must correctly guess if the card will be inside, between the first and second card values, or outside of the first and second card values. And for the fourth card, the player must correctly guess the suit of the card. Today, we are going to determine the chance of winning, assuming the player always chooses optimally, meaning he makes the choice that is probabilistically most likely to win. In order to win, the player must get every question right. This means that we have 4 probabilities that must all be successful. We can call these cards 1 through 4. The probability of winning is the product of cards 1, 2, 3, and 4. Card 1 is the first card to calculate, and it is quite easy. As 26 of the cards in the deck are red and 26 of the cards are black, assuming we're playing with a full deck, there will be 50% chance to get this right, so card 1 is 0.5. Card 2 is a bit more tricky, as the chance of a guess being correct changes depending on the value of card 1. For example, if card 1 is a 2, the player will choose higher, meaning any value other than another 2 will be correct, or 48 out of the remaining 51 cards in the deck will be correct. If the card is an 8, only 24 cards left in the deck will be correct. If the player chooses lower, any 2, 3, 4, 5, 6, or 7 will be correct. And if the player chooses higher, any 9, 10, jack, queen, king, or ace in the deck will be correct. We need to create a probability distribution and use conditional probability to determine the overall likelihood of getting question 2 correct. Here we can show the frequency of the values of the first card and the respective likelihood of the optimal choice being correct. All we need to do is take the sum of the products of each frequency and chance of success, and we have the probability of the second question being correct. Card 3 gets even more complicated, as we now have 2 different cards that can be given. Rather than 13 different values, we now have 13 times 12, or 156 different potential pairs. It should be noted that the first and second cards can never have the same value, as if this were to happen, question 2 would have been incorrect already, because the optimal choice will never be correct when the second card is the same value as the first card. We can ascribe a distance of the pair of cards, which denotes the difference of the drawn pair. For example, a 2 and a 3 will have a distance of 1, and a 2 and an ace will have a distance of 12. We will need to calculate the distances of values 1 to 6 differently than 7 to 12, and we will see why in a minute. For now, we can start with distance 12 and go down from there. For distance 12 to occur, we will need the first card to either be a 2 or an ace, 8 out of 52, as no other values have a value which is a distance of 12 away, and the second card needs to have been the other value of 2 and ace, 4 and 51. This means the frequency of distance 12 is 8 and 52 times 4 over 51. We can continue this formula for distances 11 through 7, with the first component increasing by 8 over 52 with each unit of distance decreasing. Distance 11 can start with 2, 3, king, or ace, because of the distances in 2 to king and 3 to ace. The second card will always be 4 and 51 regardless. However, once we approach distance 6 and less, we need to factor in the fact that a given card's pair for that distance can be both above or below the initial card. For example, in the distance 2, if the first card is a 4, the second card can be a 2 or a 6, which is 8 and 51, instead of the 4 and 51 used for the second card for any distance over 7. For a distance of 6, only 8 can be paired with a higher and lower value. This means that given the first card is an 8 or a 1 in 13 chance, the second card could be an ace or a 2, which is 8 and 51. If the first card is any other value than 8, which is a 12 in 13 chance, the second card will only have one value for that distance, still a 4 in 51. Therefore, the frequency of distance 6 is 1 over 13 times 8 over 51 plus 12 over 13 times 4 over 51. We can calculate the rest of the frequencies for card 3 with the same formula, with the number of values which can be paired with both higher and lower values, starting at one possible choice for distance 6, which is the 8, and increasing by 2 for every unit of distance lost. Each distance will also have its own chance of answering the question inside or outside correctly. If the distance is 1 and the cards are adjacent, there is a 44 over 50 chance of the card landing outside, with a 6 over 50 chance of the cards being the same value as one of the previous two cards. For distance 12, there's also a 44 and 50 chance of the third card landing inside, with the 6 over 50 chance of the cards being the same values as the previous two cards, an ace or a 2. As the distance approaches 6, the likelihood of getting the question right decreases, and if the cards are 6 units apart, there is only a 24 over 50 chance of getting the correct answer. As before, we need to multiply the frequency of each distance with the likelihood of getting the card 3 correct for that distance. The sum is here, which finally gives us card 3. Card 4 asks the player to predict the suit of the final card. As only 3 cards have been drawn, there will always be at least one suit which has no cards showing. This means that a player can always pick a suit which has 13 cards in the remaining 49 cards of the deck, giving card 4 a probability of 13 over 49. Altogether, the chance of winning around the world on any try is the product of card 1, card 2, card 3, and card 4. Which is here. I don't know it yet. I'm still recording the video, but I'll do the math, and I hope it's right. Keep it tropical. Love you guys.